Good morning, everyone. Let's quickly talk about what my daughter asked moments of the force. Now, when we say moment, we're talking about the turning effect in physics. A turning effect, like the free flow or movement of an object in a clockwise direction. That's what we meant by moment. Of course, when it's not moment of a force, there's an application of a force that brought about the twisting or the connection or effectiveness of that, whether you're locking up or you're closing on. So these are what we mean by what moments of the force. Although there are several factors that had to be in place for us to have an effective moment of the force. That is, the movement of the clockwise reaction must be equal to the movement of anti-clockwise. Now, for example, let's look at the wall clock as an example. In a wall clock, we have calibration of 1 through 12, a 12-hour determination. If it's 24 hours, it will be continuous like that. Let's say we're using a 12-hour calibration. Now, it goes through the midnight, 12 a.m., 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, another 12, noon, completing a circle of 12 hours on each intervals. The same way we do on longitude and latitude, the equator being divided, and the lines of imaginary lines that cut or bisect the equators. But that's not where we're going. We're going in details about discussing what the moment of a force actually means. So when clockwise reaction equals anti-clockwise reaction, then we say there's a total effect of what? Of a moment of a force. Mind you, we have a motion that is attributed to all of these effects. When it's partially semicircle and when it's a complete circle. So if it's 360, it's not all moments of a force. That's a turning effect. But if half a semicircle, then it's a moment of a force. Because opening up will require you to loosen it up and get close. Now I'm using the tap as a case study for all of these my illustrations. So moment of a force is associated with a circular force that's called the centripetal force. The centripetal force is the motion around a circular object. So we have a couple of terminologies in moment of a force. We have the torque, we have the couple, we have parallel forces, non-parallel forces, we have planar forces and coplanar forces as well. Now, it depends on the calibration of the movement, because before this moment of a force, you would have known something on the scalar and a vector quantity or vector representation, where we talk about when vectors are moving on the same direction cardinally, that it's to be what? It's to be added, north to be added, south to be added, east to be added, west to be added. But when it does change its direction, that is going north and south and west, east and north, or east and west, or south and east, then it becomes different direction and it is to be subtracted. The larger one takes away the smaller one. Then when it's in opposite direction, we use what we call the Pythagoras theorem or the triangular method. You can use the cosine rule there. So all of this has been learned before. Now yours is just to identify the representation of the vector in the direction is to be pegged. So if the vector is having a direction of, let's say, north, and there is an east direction, so we know we are combining with Pythagoras theorem. What do we mean by Pythagoras theorem? We'll be looking at theorems of what two shorter sides have been given. How do we close up the smaller side? That's the hypotenuse. Either you're given the opposite and the adjacent, then you have your hypotenuse. You know, the square of both your opposite and the square of your adjacent will give you what? The root of, square root of your what? Of your hypotenuse. So that's what Pythagoras theorem is all about. Now in cases where the angles are inscribed, let's say it's obtuse angle now, is lying on a what? On a plane surface. An angle is inclined. You will be given a primary angle. Now the primary angle could be an acute angle, which we call complementary angles that are greater than 45 but lesser than 90 degrees. Now if it is inscribed using the law of your angle on a straight line to demarcate it, you will be having something like, let's say I give you 65 as an inclined angle in an illustration of two vector representation. Now I expect you to look for the compound one that will sit on the obtuse angle to be obtained. So meaning the angle on the straight line is 180. 180 minus 65 will give us 130. 111. Sorry. So 100 and that's 45. So 65 minus 180. So that will be like 115. Yeah, if I'm not mistaken. So 115, 5501. That's it will give you 180 back. So we have 115 in the cosine of the both sides that will be given. And that's what we call the triangular method of representation. Now, in the moment or moment of the force, I talk about the couple. Now, actually, the couple are those pairs that comes together to give you the validation of what the turning effect will look like. The tug is the perpendicular diagonals that bisect, that shows like the mouth of the tap now is perpendicular. So the perpendicular shows the direction in which the couple is placed. Now, that is in respect to whether it's clockwise or it's anti-clockwise, right? But it's what? It's in that direction it's placed. So meaning you could have, for example, not a tap, let's say the handle of a door to be switched on like a semicircle, to be pulled up again if it's not a jam door. So all of this are being inscribed in it. So these are what few moments of a force. Now, how do we operate this? And what brought about this? That's what brought about. We'll talk about balancing, mass balancing. It's simply called harmonics in physics. We have a sphere of physics that is called harmonics, balancing, harmonics. What are harmonics? What are balancing? We talk about the pegging of a meter rule to give you the required balance on when masses are suspended on both point A and point B. Mind you, we've talked about the differences between distances and displacement even before you did about vector representation. So there's a knowledge of distances that needs to be used when you are to apply this in the moment of a force. Fair? I thought I've answered your question. Thank you.